Hello, everybody. Today you realize how smart you actually are. Uh, it's all about justifying your actions, and today we're going to learn that all these things that you've been doing are justifiable, and the more you get in that mode of justifying your work, the more people are going to believe you. So let's start off with a quick little, let's do number two here. Whoa, what we're looking for on number two is to rewrite this as in three different angles. Well, I see this angle right here, so I'm going to say angle EHF. Maybe this angle, angle EHG. Oh, maybe this one right here, angle FHG. Um, Angle H equals what? So this is a bad one. So you wouldn't want to say angle H because it's like, yeah, all right. So the essential question is, how can algebraic properties? So properties are addition, subtraction, distributive property. Whoa, wait a minute, we've been doing that. So now we're going to just use it to our advantage. All right, this is where you pause and you write this down. This, instead of like here and here and here, I put them all in one page so you can reference that. So what you need to do is probably you could replace, let's do this, this right here. You could write POE. Write property of equality on the first one, then POE on everything else. Distributed property, great. And then the blue box only, I think, is all you need for your notes, the blue box. This is just kind of it in a different way. So if you say 3 is equal to 3, that's neat and all. Here you're saying the length of AB is equal to the length of AB. And that's kind of cool too. But I think you get the point when you just write what's in the blue box. All right, pause it, write those down. And you're back. And you have this, hopefully, in your notes, and we're going to reference it. So here we go. All right, so we're not going to work with a partner here. We're just going to show you that these are algebraic steps that I think you should be able to do at this stage. If you're getting there, that's awesome. If you're getting better, that's awesome. But let's say you start here. The first step here would be to do this move, and that's where the 2x and the 6 come from, you bet. If you combine these two, 6 minus 5 is 1. Great. It looks like we're going to subtract 2x from both sides. It looks like we're going to subtract 4 from both sides. And then at the very end, we would divide by positive 3, and we get negative 1. Great. So can we justify these steps? So what did we do from here to here? So that's what would go in this, and that is called the distributive property. Now, maybe you know this, maybe you don't. I'm not worried about that right now. I'm just showing you how this looks. This is what, if at the end of the day you could do this, great. This is what we're looking for. So this step right here covers me from here to here. So from here to here, you could say, well, 6 minus 5. I did subtraction. Right about now, most people start leaning back, going from, I have no idea what he's talking to, be like, wait a minute. All right. So what did we do from here to here? It looks like we decided to subtract 2x. So guess what? That's subtraction. Do you see where I'm going with this? All we're looking for is for you to now put this new column into algebra. It's called the justification. And that's where here you're just stating something, but here you're justifying it. You're saying, why can I do that? Usually we don't have to do that in algebra. We know that you can add 1 to both sides, but this is a little bit more formal way. So this is There are three sections to that piece that I gave you. The first part are the algebraic properties, and these are the things that you should feel really comfortable with. Hey, well, you can add, you can subtract, multiply, and division. I would say this is kind of the new one. This is the new one. This right up here. So what does that look like? Well, that means if I knew something, if I knew like x equal to 3, and later on I had x in an equation, I could plug 3 in, or I could substitute 3 in for x. So anytime you're saying, hey, I know what that is, and you're plugging that in, that's called substitution. Awesome. All right, let's do our first example. Yes, your homework looks like this. So the first thing you want to do is maybe nice clean start. 3x plus 2 equals 23 minus 4x. All right, if I'm looking at this problem, I want to get the x's on one side and the numbers on the other. So I'm going to add 4x to both sides. Okay, now I'm going to justify this with addition. Property of equality. And what do I get? 3x plus 4x is 7x plus 2 equals 23. Nice job. So what would you do next? I'm going to subtract 2 from both sides. That is subtraction. Property of equality. Yeah, I know. It's like, come on, what's, so I get 7x equals 21. Next thing I'm going to do is divide by 7. Division. Property of. What makes this, I have no idea what just happened. What makes this so nice is we're using things that we feel really comfortable with. We're learning a new technique, but we're using things that, come on, that's nothing new. Well, that's good. The new part is justifying. So don't overthink this and think, oh man, I don't know. X equals 3. So we're done. We finished it. We've justified it. Life is good. I think you can do it. This problem is exactly like we did before. I will do it for the notes. So when I present this in the PDF. So the distributed property is a fancy one. I think most people have been given an opportunity to know this. If this is your first time, if you have this notation where you have a number outside parentheses, then all you do is distribute, and that's why the word distribute, just like you would distribute food, distribute money, whatever. You're giving that to all the B and the C. So you end up with AB and AC. It works when there's a subtraction also, so no big deal. So let's do this and justify each step. So we start out with a nice clean copy. First thing I want to do is distribute. So I would get negative 35W minus 40 equals 30. And so I would write this as this distributive property of equality. Well, now I'm just going to solve the problem just like I would. I'm going to add 40 to both sides. Oops, I forgot my 0 there. So I get negative 35W equals 70, and that is addition. That's why I can do that. Nobody's going to argue. Yep, you're right, Mr. Sayers. And then finally, I'm going to divide both sides by negative 35, and I get W equals negative 2, and that is division. You'll only see this in this math class, but I like to write, when I finish it, I'm like, bam, I got that. I'll bet this looks exactly the same way. So I will do this for your notes if you want to go look at another set of notes, and that should help you. So these are kind of new, and you wrote them down because I asked you to. The reflexive, the symmetric, and the transitive properties. So what those are they allow us to kind of, say some things and justify it. Something is equal to itself. It's so remarkably, are you kidding me? But in like a court of law that wants everything to be precise and perfect, it's actually a necessary step so that you can use it in other instances. It's hard to explain, but I would not waste your time unless we needed it. So that is called reflexive. A great way to remember that is if you look in the mirror, who do you see? Yourself. Reflexive. Hey, Mr. Sayers, Mr. Sayers, nice to meet you. Okay. So that's a reflexive. Symmetric is you're switching the order. So if you start out with A equals B, then B equals A. Oh, I think you noticed the if-then conditional statement. So that's why we kind of messed around with those before. Transitive property is probably the best. This is where we're going to use all the time. We're working hard and we've established, hey, we know that A equals B. We know that. And then we've worked a little bit harder and we've said, hey, B equals C. So do you see how if they both equal B, don't they equal each other? So we can conclude that A equals C, and we could say that conclusion is because of the transitive property. All right. These are just different, segment lengths or angles. It all works. But if you kind of remember this in this general way, life's good. Life's good. Let's do some examples. What I've done is I've made a little copy for myself. I asked you to write your notes. This is where your notes need to be out. I don't know if you can memorize this the first time you see it. So if you have those notes, then it makes it easy. All right, number 7. The statement is, hey, the measure of angle 6 equals measure of angle 7. Great. Then I want to say that the measure of angle 7 equals measure of angle 6. And I can say that not by duh, obvious, maybe that's what you want to say, but there's a fancy word called the symmetric property. So I would write symmetric property. The symmetric property allows us, if we know this, then I can write 7 equals 6. That's great. Hey, 34 degrees equals 34 degrees. Yep, just like I said, Mr. Sayers, if that is the reflexive property. When you say something equal itself, reflexive property. And finally, if 1 equals 2, so we have these two angles, they equal measure, and 2 equals 5, this other measure, then I'm going to be able to say that 1 equals 2. So that's the conclusion, and I can say that and justify it to the world because I'm using the transitive property. It's pretty awesome. Do you see how I can look at this and have this and kind of go, oh yeah, that's that one. Oh yeah, I feel like that. Oh yeah, that's what we're doing. So that's what I want you to get used to. Well, look at that. There's more. Let's do the first one. If we know that JK and KL have the same length, and KL is the same length as 16, can't we put those two statements together and end up knowing that JK has to be equal to 16? Transitive property is huge, okay? And that is the transitive property. Mr. Sayers, I see that as substitution. And you know what? Substitution is okay. If you justify that by saying you're substituting the 16 in for KL, I love it. It works. Substitution and transitive kind of work together. At this stage, there's no reason to fight it. Kind of use both. There's like more precise nuances that allow us to say transitive over substitution, but that's good. Hey, something equals itself. Reflexive. Hey, we switch places here. Symmetric. I think you got this. I hope. All right. 25 through 32, the exact same. Reflexive. Ooh, here. This is interesting. We multiplied both sides by 3. But Mr. Sayers, you have this. I'm sorry. I meant to have this list, the whole list. All right. So that last one would have been multiplication because I multiplied both sides by 3. All right, this is your ticket out the door. Please, at this stage, write on the play posit what you think the answer to A and B are, and we'll be good. And we're back. Hopefully you recognize that we have AB equals CD. Then what we've done is added FE to both sides. So this is addition. So you're looking at the change from the original statement to the next one. And here we know 2 and 4 are the same measure, 4 and 6 are the same measure. So we can conclude that 2 and 6, since they share that, and that is the transitive property. Cool. I will see you tomorrow.